Good afternoon, everybody. My name is Henrik, and I'm the CEO and co-founder of CustoMem, which has been supported by a wealth of organizations, including Sinby City, Climate Kick, represented by Ton, and Royal Academy of Engineering. So at CustoMem, we make novel biomaterials that filter out harmful pollutants in industrial wastewater. I'll talk you through how that works just in a second. So what we are facing is a time where there are increasing focuses on water filtration companies. But there are segments of this that includes micropollutants that are very difficult to remove, persistent in the environment, and toxic to humans. This is being recognized by regulatory bodies where we stand. So in the UK, we have the Environmental Agency, and in the EU, we have the Environmental Water Framework Directive, including the EQSD, shown here, which have identified 26 priority hazardous substances that are toxic, persistent, and very difficult to remove. We focus on removing these as a barrier from the industrial factories that discharge them. And we've identified 3 barriers that are holding back the removal of these priority substances. Our first focus is on halogenated organics, and here we have the 3 characteristics. One is that these are man-made chemicals with very complex chemistry, which means that they are difficult to target, and this chemistry means that 2 existing treatment processes cannot be used. They cannot be oxidized with oxidation processes like advanced oxidation process, and they cannot be degraded due to their synthetic chemistry. So to tackle this first barrier, we've developed an engineered polymer production method, as you can see on the right, and that gives us targeted chemical removal of these halogenated organics. Now the second barrier for removing these priority substances is the energy consumption. Right now, using advanced oxidation processes, you will be spending up to 1 kilowatt hour per meter cubed to remove these chemicals. We offer a solution that targets these chemicals and uses 110 times less energy per cubic meter of water treated. Now that translates to a lower operational expenditure, and for our customers, this is so attractive that we're now doing 3 lab-based pilots with a chemical manufacturer from the Switzerland area, with a waste processing center from Scandinavia, and also with a water treatment company from the UK, because these guys recognize that we're addressing an unmet need around these priority substances. The third barrier is around the disposal. So what you see when the material comes out of these tanks is that you need to dispose of the chemicals attached to the material. And that's a main barrier if you don't have a pipeline for it. With our targeted approach, we enable safe, responsible repurposing of these chemicals, either through incineration or through recycling. So this slide is really summarizing how we're tackling these barriers. What we have is a biotech solution for a water treatment problem. We start off with a renewable feedstock, as you can see in this, and then we use our engineered polymer production method. This is where we focus first part of our IP. That gives us our granules, which are sterile, there are no living bacteria in the product, and durable. The benefit of their formats is that they retrofit into packed bed vessels like the one seen in the middle, so you have lower capital expenditure. Now, the third benefit is then around the regeneration and recycling, where we can reuse our materials. The reason I'm the most excited about being here today is really because of the team. Gabby and I have a long track record coming out of Imperial College, representing Imperial College for the world's biggest synthetic biology science competition. And we've brought in a really strong core team, 4 full-time, including Ben, Amanda, and Shane. We're supported by a world-class advisory board. We spun out of Dr. Tom Ellis's lab at Imperial College, and we've later gone through accelerators that have brought in world-class serial entrepreneurs, like Dr. Richard Philpott, who was involved with a water treatment company called Wattman, and more recently with Burst Technology, a water treatment company in Silicon Valley. Our other programs have brought in advisors like John Banyard, who is very hands-on and a former asset and R&D director from Severn Trent Water. And most recently, we've focused our attention on the key market players for our market segment, including Steve Glock, who used to be the former tech leader from Dow, Process, and Separation Solutions. He used to be in the role that would acquire companies like us. Finally, I am here today because we are doing lab pilot testing, and we are raising £1 million later in the year in order to do field pilot testing. Right now we're in talks about a testing proposal that will lead to one potential field trial. That means we can spend that £1 million to do a successful field trial pilot alongside supporting our strong IP with at least 2 key patents granted within the next year. We already have a PCT application in place on the 27th of May. In the following stages, we can then look towards UK processing and contracted manufacturing, because our production and manufacturing retrofits into an existing manufacturing pipeline. So finally, I'm just here to try and enthuse you guys about our vision around tackling unmet needs in industrial wastewater, and I would like to thank you all for listening.